All right, good afternoon. Welcome back. I'm just putting my bag away. Give me 1 minute. All right, let's get going. This is our last class, and I'm sure you already know. And we're not going to spend a lot of time talking today because we're pretty much done with the material. We have like a bit left. So we're just going to finish it, and then we're going to end the class early. I'm just imagining we're probably done before 7. Are there any questions before we get started? I know that you're probably still wondering about the quiz 4 and the exam 3. I'm so sorry. I'm behind, but I promise you, after this class, I'll be working on it, and you should receive some email about the grades and the feedback for those 2 assignments. And if you have any questions, feel free to email me back, and we can look at it together. And if there's any issues, I'll try to address it before I submit the grades tomorrow. Remember that the final homework is due tomorrow night at 8, so Eastern time. So if you're in a West Coast, so it's not 8 o'clock West Coast. So just be mindful about the time difference. I know that some of you probably not on the East Coast now, so just be careful with the time on the deadline, because there's no other way to go around about that. And the grades will be submitted tomorrow, sometime tomorrow before midnight, and you're probably going to receive some kind of notification. If not, you're going to receive it in a few days. You can, if you're a UNH student, you can also check on what's it called, a webcat for your final grade once the system updates that information. All right. Any questions or any concerns before we move into today's lesson? All right, then let's just get going. So there's one problem I left out yesterday. So let me go through that first. So the question says 2 radar stations 20 miles apart. This problem is taken from the book, and a plane is flying between the stations. So a plane is flying between the stations, and from station 1, the plane is observed at an angle of elevation at I forgot to put the degree there, at a 15-degree angle of elevation. And from station 2, the plane is observed at a 35 degrees angle of elevation. The question is, how far is the plane from radar station 1? So I'm going to draw a quick diagram. I think a diagram will help. So here you have those 2 radar stations, and then you have a plane flying between. And from the station 1, looking at the plane, the angle of elevation is 15 degrees. And from station 2, looking at the plane, the angle of elevation is 35 degrees. And we know that the distance between those 2 stations is 20 miles. And we're looking for the distance from the plane to radar station 1. So we're looking for this side. essentially it's a triangle problem because we can just look at the distance between plane to the radar station 1 as one side of the triangle, and then you have another side that's 20, and then you have two angles given. So this is the case that we have angle, side, angle. And if we want to find the missing side, let's just call the missing side x. And if we want to know how big is this x, we can use law of sine. So let me use alphabet. So that's called this angle A. This is B. This is C. So if I want to find x, I can use x is the opposite side from 35 degrees, angle B. So we get sine B over lowercase b equals, and the 20 is the opposite side of C. So that would be sine C over lowercase c. So 20 is the lowercase c, x is the lowercase b, right? So if we have angle B, which is 35, we don't know the side B, that's what we're looking for, x. And we don't have angle C, but that's okay because we already have two angles. So first step, we need to find the missing angle C. We're going to use 180 degrees minus 15 degrees minus 35 degrees. So that's going to equal to 180 degrees minus 50. So you get 130 degrees. So that's angle C. And then we have a lowercase c, which is 20. So now we can plug into this equation. So we get sine B, B is 35 degrees over lowercase b is x. That's equal to sine C, 130 degrees, divided by lowercase c, 20. So we have this equation and we can solve for x. Cross multiply. So we get 20 times sine 35 degrees equals x times sine 130 degrees, and divide by sine 130 degrees to isolate the x. So x equals 20 times sine 35 degrees over sine 130 degrees. So that should give us the correct x value. And if we do everything correct here, so we get x is about 14.98 miles. Any questions about this problem? No, so that's x, which is the distance from the plane to the angle A to the radar station 1. Now, suppose the question is having a second part, which says what is the plane's altitude or elevation. That's looking for the direct height of the plane from the ground. And in the diagram, so that's this part, that's what it's looking for. So how high is the plane basically? How do we find it? Well, we have the angle, if we draw the height, we get two right triangles. We have the angle A is 15, and then we have the x equals 14.98, and we can use the triangle on the left. I'm just going to create the triangle on the left. This is point A. This is where the plane is, C, and we draw this height. And I don't know how long this is because together that's 20, but I don't know the first part, but I know this is 14.98. This is the angle 15. So that's the right triangle on the left with the height. So how do we find this height? Well, this is the right triangle. We can use SOHCAHTOA. So height is opposite from 15. We have the hypotenuse. So we're going to use sine 15 degrees is equal to the height divided by hypotenuse 14.98. Multiplied by 14.98, we get height equals sine equals 14.98 times sine 15 degrees. And that's going to equal to about 3.88 miles. So that's how we find the altitude. So taking the non-right triangle and then convert it into right triangles. Any questions on this? All right. So the next part I'm going to talk about, if you don't have any questions, is law of cosine. Again, I imagine that some of you have seen it before because that's a typical section in the Algebra 2 Precalculus curriculum, the law of cosine. But nevertheless, I'm going to just do my best to explain everything here. So suppose I have a triangle. Let's just make it easy. It's an obtuse triangle. Let's call this A. This is B. This is C. And the size we have, this is lowercase a, this is lowercase b, this is lowercase c, right? Non-right triangle. And let's just say I'm going to extend this AB so that I can draw a height from C. So that's a height. Let's call this point D. And this height, so let's just give me a minute. So I'm going to place a XY coordinate plane right at point A. So this distance, AD, I'm going to call it X. And this height, I'm going to erase it. I'm going to call it Y. So this is a Y. And that leaves BD, this distance. We know that A to B is C and the A to D is X, so BD will be X minus C. And in this right triangle, the small right triangle outside of the original ABC triangle, triangle ABC. So this shaded right triangle we have, it's a right triangle, so we have Pythagorean theorem, which says that X minus C squared, one leg squared plus the second leg squared, Y squared, must equal the hypotenuse squared, which is A squared. So that's what we know. So A squared equals X minus C squared plus Y squared. Okay. And I'm just going to rewrite for the A squared on the, I'll do that later. Anyway, so that's using the green, the small triangle, small right triangle. So B, C, D. So from that small triangle, small right triangle, we can get this. So that's the A, this is the X minus C, this is Y. And if we look at the big right triangle, ACD, and forget about the B in the middle. So if we look at ACD, so this is the B, this is the X, this is the Y. So we have another Pythagorean equation. So that's going to be X squared plus Y squared equals B squared. And we also have from this equation, let's see, this is the angle A. We also have from, this is just set up. So from this this right triangle, we have cosine of angle A is equal to X over B. So we're probably going to need all this. But anyway, so that's from the two right triangles. We can extract those information. So now I'm going to go back to the first equation I wrote and then rewrite the equation by putting A squared on the left. So A squared equals X minus C squared plus Y squared. I'm going to expand the parentheses. So X squared minus 2CX plus C squared plus Y squared. And I'm going to replace X and the Y with the correct terms. So I have immediately, I have X squared plus Y squared. But remember, we have equation here that says X squared plus Y squared, that's B squared. So I'm going to replace X squared with plus Y squared with B squared. So B squared minus 2CX plus C squared. And I need to replace the x as well. From cosine A equals x over b, so I know that x equals b times cosine A. So b squared minus 2c, and x I'm going to replace with b cosine A plus c squared. So now I have a squared is equal to the expression with only b, c, and the angle A. If I rewrite everything nicely, so a squared equals b squared plus c squared minus 2bc cosine angle A. So I'm sure you've seen this before. So that's the law of cosine, one of them. And equivalently, we can write down b squared equals a squared plus c squared. So if you have b squared on the left, then you're going to take the other two sides, a and c, a squared plus c squared. But it's minus 2ac cosine b. The way I remember that the a squared, the a, it's always related to the angle inside cosine. So b squared, the b on the left, always going to tell me that's going to be angle b in the cosine. And the last one will be c squared equals a squared plus b squared minus 2ab cosine angle c. So those three are the law of cosines. You're going to have to use whichever you want. But generally speaking, really, they're just the same formula with different starting side and the angle. Let's look at example. It says given A equals 10, C equals 12, and the angle B equals 30 degrees in a triangle. So solve this triangle. I'm going to draw a diagram quickly. So we get A, B, C, and the side A is 10. So that's offset from angle A. Side C is 12 over there. And angle B is 30. Perfect. I want to point out one more thing with the formulas that the angle A. So if you have B and the side B and the C in the formula, the angle A is always the angle between. Okay, so now let's take this and then we're going to solve. We cannot use law of sine here because we don't, if we want to use law of sine, so cannot use law of sine, because if we write down the expression, for example, we have angle B, so if we use sine B over B equals, let's see, sine A over A. And the issue here is that we have angle B, which is 30 degrees, but we don't know side B. We also don't know angle A, even though we know side A equals 10. So we have two missing parts in this proportion. We cannot solve for anything, so it doesn't help us. But we can use law of cosine because we have two sides, and then we have the angle between them. So because we have, so this is side B, because we have angle B, so that's going to go into cosine. That means on the left side, I'm going to solve for B. So B squared equals A squared plus C squared minus 2AC cosine B. We already know the angle B. So now we're going to plug in what we know. So B squared equals A, which is 10 squared, plus C, 12 squared, minus 2 times 10 times 12 times cosine angle B, which is 30 degrees. As you can see, we have all the values we need on the right-hand side. We can find that, and then we can take a square root. So it turns out that b equals, we're going to drop the negative, it's just a positive 6.01. So that's the b value, it's an estimate. Now, after we get b, which is 6.01, and then now we can use, so we have b, now we can use law of sine to find angle A, because we have b, we have angle B, we have A. So we can use that formula, so we get sine B, which is 30 degrees, divided by the side B, 6.01, which is equal to sine A, we don't know what angle A is, divided by lowercase a, which is 10. And from here, we multiply by 10 on both sides. So 10 sine 30 degrees over 6.01, that's equal to sine A. And then we can find the inverse of sine on both sides. So A equals inverse sine of 10. Now sine 30 degrees is half, so 10 times half divided by 6.01. And we still need a calculator. If we put this into the calculator, we get A to be 56.3 degrees. Okay, so let me write it down on the side. So A equals 56.3 degrees. Now, you probably wonder, last time when we talked about law of sine, when we use the inverse sine on both sides, we find the angles and we have to subtract the angle from 180 degrees to find the symmetric angle. Do we need to do here? Do we need to find 180 minus 53, 56.3 degrees is going to give us 123.7 degrees. Is this angle going to be useful as a second angle? Now the answer is no, because this triangle now is becoming side, side, side. We have all three sides. That means the shape is fixed. So there's not going to be a second variation of the triangle. It's different from the angle side, side. So we don't need to do this because it's not angle side, side case. The only time you need to consider the second angle is if you begin the problem with angle side, side, and then you use law of sine to solve it. That's when you need to consider the second case. But if we use law of cosine first to find some information and then use law of sine, we don't have to worry about anything because the shape of the triangle is already determined. So that's angle A, and then we can find angle C because we know that angle B is 30. So C equals 180 degrees minus 56.3 minus 30 degrees. It turns out to be 93.7 degrees. So now let me just redraw the triangle A, B, C. So we have B is 30, the degrees. This side is 10, this side is 12. This side we found out to be 6.01. And this angle we found to be 56.3 degrees. This one is 93.7 degrees. Now you can always check quickly. For triangles, the bigger angle is always opposite from the largest side, the longer side. So the longest side corresponding to the biggest angle, the smallest side corresponding to the smallest angle. So if I quickly check, the 30 degrees is the smallest angle, so it's corresponding to the shortest side. And 93 degrees is the biggest angle, it corresponds to the longest side. So that's always true. Any questions about this example? Okay. All right. If you don't have questions, I'm going to move on to the next part. Again, just a different example. So we're going to solve this. So solve for angle A in the triangle. The triangle has A equals 20, B equals 25, C equals 18. That's all we know, three sides. So if we graph it, let's see, this is A, B, C. This will be A equals 20, B equals 25, C equals 18. Okay. That's all we know. We don't know any angles. You probably wonder, okay, which formula do I begin with, right? Which angle do I find first? It doesn't matter, but since we're looking for angle A in this case, if we solve for the triangle, you can begin with any formula, but we're looking for angle A. So we want cosine A in the formula. So that means on the left side, I must begin with A squared. So A squared equals B squared plus C squared minus 2BC cosine angle A. That way I can solve for this directly. So A is 20 squared equals B squared 25 squared plus C squared 18 squared minus 2 times 25 times 18 cosine A. And we have those numbers, but we don't know A, so we're going to isolate cosine A. So minus 25 squared minus 18 squared, 20 squared minus 25 squared minus 18 squared equals negative 2 times 25 times 18 cosine A. And I'm going to divide both sides by that same product. So we get 20 squared minus 25 squared minus 18 squared divided by negative 2 times 25 times 18 equals cosine A. If I have a calculator, I can put in the calculator and try to figure out what this number is. And I don't have it with me. So the last step is find the inverse cosine on both sides. So inverse cosine of this expression, I'm going to be lazy, hopefully that's okay. Of the fraction there, that's going to equal to A. And it turns out that A equals 52.4 degrees. Any questions on this? So again, there's no second angle or second triangle because when you have side, so this is the SSS case. When you have all three sides given, then the shape is already decided. There's no different way of creating the triangle. All right, so at this point, I'm going to introduce something called the Heron's formula to find the area. So Heron's formula to find area of side triangles. Which says that if we know all three sides, if we know all three sides of a triangle, let's just say the ABC, A, B, and C, then the area of the triangle equals square root of S times S minus A times S minus B times S minus C, with S being the average of ABC, or the semi-parameter. So A plus B plus C is the parameter of a triangle. So if you divide by 2, you can think about that's the semi-parameter, or you can think about that's the average of the three sides. Oh, not the, oh, I don't know what I'm saying average. It's not average. I'm so sorry. My head had to get ahead. And so this is not the average. This is just the semi-parameter because the average would be dividing by 3. So that's what S is. So for the given example, we have all three sides, which is A is 20, and the B is 25, C is 18. So in the example above, A equals 20, B equals 25, C equals 18. And if we want to find area, we can find the S first. S equals, so A plus B plus C, 20 plus 25 plus 18 over 2. So let's see what that gives us. I'm going to have to take a little bit more time. So that's 45 plus 18. So that's a 3. 63 divided by 2. So that's a 31.5. So that's what S is. And now I'm going to put this into the area formula. So the area of this above triangle is going to be square root of 31.5 times S, so 31.5 minus 20 times 31.5 minus 25 times 31.5 minus 18. And if we have a calculator, we can type everything that's into the calculator and end up with the area. I think the formula itself is rather easy to use because all you need is 3 sides. If you have them, then you can find the area. By the way, I want to point out that I was, obviously I've seen this formula before, but I haven't really used it in sort of like a practical sense. But I was reading the notes, and Heron is Heron of Alexandria, and he is actually born in the 1st century AD. I even spelled century right. You know what? I probably didn't even spell century right. Anyway, double check. That's a U there, right? Anyway, so I was just amazed, like back then, the people didn't have computers, didn't have calculators, but they were able to, mathematicians or scientists was able to come up with a formula like this. And I just thought that was pretty amazing, with just pen and, pencil and a paper to come up with something that, well, we used for so many years. But it was just amazing that the derivation that they were able to come up with it. All right. So I have one more example here related to this. So the next example I have is a boat. Oh, by the way, any questions about the area formula above or finding the area for side? Okay. All right. So the example I have is a boat leaves a port, travels for 10 miles, then turns 20 degrees. After that, travels for another 8 miles. So the question is, how far is the boat from the port? So obviously, we're going to look for the direct distance between the boat and the port. So let's draw a diagram. So let's see the boat, the port starting here, the boat starting here at the port, and it's going to travel 10 miles. At this point, then it's going to turn 20 degrees. It doesn't really matter which way it turns because we're just looking for the distance. So let's see it turns. So that's the path it's supposed to go, but now it turns 20 degrees and follow this path to get there. for another 8 miles. And we want to know the distance from the port to the boat at the end. So this is the boat. How do we find this distance? Well, if we consider the path as a triangle, we have one side is 10, the second side is 8, and we have an exterior angle is 20, but we can take the 20 and translate it into this interior angle, so that's going to be 160 degrees. Because the exterior angle and the interior angle next to it, the adjacent interior angle, they are supplementary. So 180 minus 20 give me 160. So now we have the side angle side, and then we're looking for the side offset from 160. We can use law of cosine. So let's just say this side is A, this side is B, this side is C. That's what we're looking for. And then the angle 160 will be angle C. So we have C squared equals A squared plus B squared minus 2AB cosine C. C squared is what we're looking for. So C squared equals A, we know it's 10 squared, and a B we know, which is 8. We get 8 squared minus 2 times 10 times 8 cosine angle C, which is 160 degrees. And since we know everything on the right-hand side, we just put this into the calculator. We can solve for C. At the end, C equals 17.7 miles. A problem like this, you can also quickly check, right? Because it travels in one direction, that's 10, and it tends at an angle travels another 8. So the actual path is about 18. But when we look at the triangle, we're looking for the side that's missing. So that's less than the sum of the other two sides. So it makes sense that we get C is 17.7, which is less than 18. And it's definitely more than the other two sides, 10 and 8. All right. Any questions on this? Any questions on law of cosine in general? Of all the examples we did today. All right. Any questions or confusions or any concerns, anything about this class, because we are really coming to an end of it?
I mean, I can't think of anything. The class was good. So.
Okay. Thank you. I really appreciate it. And I do want to apologize because from time to time, I do make mistakes. My apology for that. I should have done more preparation. And sometimes I'm a little bit behind on grading. Again, I apologize for that. To be honest, I wasn't like this before. Before the kids was here, the child was here, I was actually pretty good with timing, but things have, being a bit chaotic and slow. But anyway, I hope you guys had a good term, and I hope you at least learned something with pre-calculus, because you do need to have a good foundation in order to do well in calculus class, and also in later on, I don't know if you continue the math class in the future. And I hope you guys have a wonderful term and that your classes begin. I see that Jonathan is probably in the dorm already. So your classes probably begin, was it Monday or Tuesday? I always forget.
I think it's Monday, but I'm not sure.
Okay, yeah, UNH is a bit weird in terms of first day of classes. But anyway, double check your schedule, and I hope you guys have a wonderful semester. And I might run into you on campus. But anyway, so I apologize for all the delays and mistakes. But anyway, so have a wonderful weekend, I guess, before you get back to the busy routine, and good luck with everything. If there's anything, any issues with the grades, please let me know. And I promise you, like I said, I'm gonna work on it right now. So send me an email after you get your grades, and I'll try to resolve it tomorrow. And other than that, and good luck with everything. All right. Thank you, guys.
Thank you so much.
Take care. Thank you. Take
Yeah,
care.
thanks.
Bye-bye. Yep.
Yeah, this is this is my second time taking this class. I flunked it in the spring because I everything just goes by kind of fast. But honestly, like I think like this is a pretty good class,
Oh,
especially for
thank-
like a summer semester deal. I'm super appreciative of that.
okay. Thank you, Brian. I really appreciate it. And thank you for being part of the class. And great. Good to know.
Of
Thank you.
course. Yeah, have a good one, man.
All right. Take care.
You too.
Goodbye, Brian.